Okay, so for today, like I was saying, we're going to express each relation as a table, a graph, and a mapping, then determine the domain and the range. So what I'd like to do is I'm just going to grab this piece right here because I don't have enough room to write. I'm going to copy it, and then I'm going to go down to the bottom here, and we're going to paste it, and then we will go forward. All right. All right, so here we go. Let's do this now. All right. And now, again, some of this stuff I don't really think is all that necessary. But it's good to know, maybe possibly on an SAT or ACT, or if you go to college, we still use mappings. All right, they're essential for really high level math. So this is kind of like an introduction. All right. So with that, express each relation as a table. I'm pretty confident everybody can remember what a table is. All I need you to do is just graph an X and Y table like this, right? And we're going to put X here and Y here. All right. And so all of the X's go into the first, and then the Y's go in the second. So we say 4, 3, -2, 2, 5, -6. I'm pretty comfortable with you knowing how to do that. All right, that's considered the table. All right. Now, the reason why you have graph paper is so you don't have to write your own. Okay. So if I was going to put in graph paper, all right, what I would want you to do is, let's just go ahead on your graph paper that I gave to you. Now you just plot these points. All right. So if you plot 4, 3, does everybody remember you go over what? To the right 4, and then you go up 3. All right. Now, this is all, well, not new, I should say, but if you don't know it, it's just basic information. So there's nothing to be confused about. All right. Does everybody agree we go over 4 and up 3, right? Anybody have a question plotting a point? Now you would plot the point -2, 2, which means you go what? Left 2, and then you go what? Up 2, left 2 and up 2. All right. So if we go left 2, that would be -2 and up 2. And there you have it. And then, of course, 5, -6 means you go what? Right 5, and then what? And then down 6. All right, so that should be good enough, and just put a dot there. All right, I know that's really simple. All right. Now, a mapping, all right, is done using ovals, I should say. So this right here is, you're going to have to draw like a little oval. And then, believe it or not, this is the domain. And this is the what? The range. Domain stands for all of the what? X values. And the range stands for all of the what? The Y values. That's it. So generally you put them in numerical order. So I'm going to go -2, then 4, then 5. Then I'm going to do a numerical order on the Y values. So that would be -6, then 2, then 3. Do we agree with that? Now, numbers are never repeated. All right. Numbers are never repeated. All right. In your mapping. So -2 maps to what? -2 maps to 2. And 4 maps to what? 3. And 5 maps to what? -6. That is not really that hard, but believe it or not, that's how they used to do it. All right, those are considered mappings. So everybody agree, simple, right? All right, so just to make sure, right? Now, domain, if you want, I'm okay with labeling your mapping, your domain, and your range. But how did I remember domain and range? I always like to tell kids domain and range are in alphabetical order. Do we agree? And then X comes before what? Y alphabetically. So that's how I learned that the domain is the X and the range is the Y. They're alphabetical. All right. So on your mapping, you can label domain and range. You don't have to do a whole different thing for that. Is everybody good with that now? All right, so let's just knock out 2 real quick. All right, so again, you can make your table. And then plug in your numbers. 5, -7, -1, 4, 0, -5, -2, 3. And then you can graph them. Now on your graph paper, label that question number 1, question number 2. All right.
Can you do like a separate graph?
Yeah, now you're going to do a separate graph. All right. That's why I say graph number 1 and then number 2. All right. And then do your mapping. And put your numbers in numerical order for the mapping. And then do your map. From -2, you map to 3. All right, and then somebody, if anybody's unsure, now would be the time. All right, because the first test's not going to be that hard. The reason it's going to be hard for some is because you don't understand the words, like a mapping or a table or a domain or range. All right, that's all we're doing. All right.
Why did we do both of them, and like, what's the point of
The mapping, nothing really. I'm gonna be honest. All right, it's just eventually, all right, if someone decides to really do a degree in math, understanding mappings is really helpful. All right, it's just something it's like a basic introduction for you. All right, so if you ever experience this, you'll say, okay, at least I know where it came from. All right, yes.
the domain and range?
Oh.
To go in like a specific order?
Yeah, well, yeah, that we write them. I forgot to write the word up here. This is the domain and this is the range. All right, and these are the X coordinates and these are the what? The Y's. All right, so thank you for that. I needed to write that.
Yeah, that's the order.
Numerically, I just wrote from small to large, right? Do you understand me? And then I notice it goes from small to large and small to large, right? And then I connect them. Now, technically, it wouldn't be wrong if you just did 5, -7, you know what I mean? But again, that was kind of a standard that we had, putting the numbers in order, and then you did the mapping, all right, to each number. All right, anybody have any issues with that before we move on? All right, let's go back and see what's next. Okay, so now these words come up in math a lot, all right? And again, I don't really think it's all that important, but it's just things you should know. All right, does everybody agree we're dealing with X and Y's, right? When we get to higher level math, and then when you get to higher level math, you even do 3 variables. All right, but right now we just have X and we have Y. X is always referred to as the independent. All right. X is called the independent. All right. Now, how did I remember that? Y is then called the what? Dependent. Now, again, I always got those confused until someone just said, look, the y depends upon the what? The y depends upon x. That's right. X can be anything. As soon as you give x a value, that tells you what the y value will be. Is everybody with me? All right. So again, this is minor thing in math. All right. But again, I need everybody to make sure you're hearing me, that x is the independent. Y depends upon x. All right. Now, does it have to be those variables? No, you will see that in a minute. All right. So let's see if you understand. Now, some people always just read it as, well, whatever comes first is the independent and whatever comes second is the dependent. And I would say that works most of the time, but not always. All right, so let me see if you understand what I'm saying. Increasing the temperature of a compound inside a sealed container increases the pressure inside the container. So what is changing? Right? The what? Well, what are we controlling? Let's say that. What are we controlling? We're controlling the temperature, correct? And when we control the temperature, it changes the what? It changes pressure. Now, look, I understand, guys. Listen to me. I understand. This is reasoning. All right. I would prefer you be better thinkers, right? And that's what we're doing right now. All right. So when you increase the temperature, so the temperature, if you want, you can put temp is equal to the independent. All right. I don't mind if you abbreviate. All right. The temperature is the independent, and then the what? The pressure is the what? The pressure is the dependent. All right. Just make sure you know. All right, now your objective now is we're going to try to do number 4 together, and you're just going to say to yourself, this is what I think the answer is. All right, and let's see if you get it right. All right, Mike's cell phone is part of a family plan. If he uses more data than his share, then there is less data available for the rest of his family. All right, so to me, I think this is kind of obvious. The independent variable is who? Mike. Whatever he does is going to affect the what? The family. He's independent. The family is dependent upon what? Mike. All right. I hope that makes sense. So I would say Mike is the independent and the family is the what? Dependent. All right, here we go. Number 5. Julian is buying concert tickets for himself and his friends. If he buys more concert tickets, the cost is greater. Tell us. Julian is the what? Independent, and what? Are the what? Yes. The costs depend upon Julian and how many he buys. All right. And finally, a store is having a sale over Labor Day weekend. When there are more purchases, the profits are what? Greater. So someone else, tell me what. Greep, good for you, bud.
Is the amount of purchases the independent?
That is correct. And the what?
And the dependent is the profit?
You are amazing. That's it. Simple, simple, simple. All right. Independent is the X. Dependent is the Y. Now, when you get your graphing calculator, there's going to come time when you look at your information on the graphing calculator, it'll say independent and dependent. Now you know independent means the X and the dependent is the Y. All right, so I shouldn't have to tell you that. All right, so now graphing is super duper important. So I'm going to try to do a better job. What's that? Any questions? All right. So now, like I said, interpreting graphs, there's a big push to make kids do better with interpreting graphs. All right. So let's see if you understand what they're talking about here. The graph represents the distance the track team runs during practice. All right. Now, for me, I don't like this here. So at the end, what we're going to do is I'm going to put a dot, not an arrow. I'm not going to put a dot. I'm going to put, or not going to put an arrow. I'm going to put a dot. Why do you think I put a dot rather than an arrow?
Because an arrow means it keeps going.
The arrow means it keeps going. All right. And I'm not sure the track team's going to run forever. All right. So that doesn't make sense. So I think the book made a little bit of error here. All right. We're going to have an end to it. All right. So now your job is to try to interpret this graph. All right. Now you don't have to write all this out right now. You just have to listen. All right. I don't want you writing this out. All right. I'm going to make you write some more out, but you're not going to write this out. I would like someone to describe to me what is going on in this graph. Thank you. I'll let you try.
The time is going up.
The time. That, okay. Now I want to try to be a little bit more specific. All right. And exactly what you said is 100% true. As time passes, right, you get further away, right? You're running in, but I would like to know specifically, come on, guys, here's where you have to pay attention if you want to be smart. All right. From here to here, let me highlight something for you. From here to here, what's happening?
They had a break.
They got a break. You're exactly correct. Why did they get a break? Because time is still moving, but they're not going anywhere. The distance is remaining the same. That's going to be critical for you to understand that. All right. So I agree with that. Now, they start out running, correct? So let's look here now, just so we can do a really good job. From here to here, they start out running at the same rate. Do you agree? Right? Now, what I want to do is I'm going to duplicate this line, and I want you to tell me if I put it over here, they're running about the same speed. Do you agree? Because the lines are about the same, not the same length, but the slope is about the same, which we haven't really talked too much about. But now what I want to do is I'm going to shorten this, and I'm going to duplicate it. Now I'm going to drag it over here. What happened to the team? Yes, guys, they slowed down, right? They slowed down. They weren't running as fast. Everybody agree with that? All right. So watch how I do that. That's called the slope. All right. We're going to go into a lot more detail on the explanation of that. But that's what you would need to say in many respects. You don't have to write anything down at this moment on this problem. All right. I'm just showing you what is important. The horizontal lines are important, and the slant of the line, which is referred to as the slope, is relatively important for us. All right. Okay. So now let's look at 8. You don't have to write anything down. We're just looking at number 8. The graph represents revenues generated through an online store. All right. So now, again, a lot of people miss this. They don't understand how to interpret graphs. That's why I want everybody to look up and see. All right. So if I'm looking at number 8, someone want to give it a shot? I'll let you try.
So the sales and the time they're selling is going up really, really, the sales are dropping.
then it shot up again, but then it like the sales kind of evened out with the money they were making and losing. And then they gone up again.
Okay, now my question, that's a really another good description there. All right. So now please, everybody pay attention now. Let's see if I'm explaining this good. Right? Does everybody agree the sales are going what? They're going what? Up. All right. Now, here is what I need everybody to take a look at now. All right. If what's happening to the sales right now, they're going down, but do they still have sales? But the sales just what? Aren't as what? They're not as good, right? Does everybody agree with this? All right. So then, all right, what happens next? Let me find a good one. All right, so from here to here, the sales start to what? They start to go up again, right? Now, here's something that I find most kids don't understand. Again, what's this mean? Did the sales stop? They what? They didn't increase or decrease, so they remained what? When something remains the same, we say it remains constant. We say it remains constant. So let me just give you for an example. Let's say over here, this was, let's say 10,000. Let's say you sold 10,000 units. All right. So every single day you're doing what? Selling 10,000. Do you agree? Right. Now, then all of a sudden you start doing what again? Yeah, you start selling more. All right, is everybody with me? You start selling more. So time could be, you know, like, does everybody understand like the stock market? You know, they're always buying and selling stocks, correct? So this could be like, for example, this could be a new company. All right, there were no sales right now, correct? And then they came out with a new product and everybody's buying the product. Does everybody agree? Now, all of a sudden, the demand for the product goes down, right? And then let's say they upgrade something and now everybody likes it again. All right, and then it remains the same. They're still selling, but it still remains the same. Does everybody understand what I'm getting at? Right, okay, so again, everybody always says they understand this, and then I put it on the test, and not many people do very well. All right, so that's why I'm really trying to take my time and make sure you're understanding. Understanding graphs is critical to math. All right, super important. All right, just because this is going down, all right, does that mean our sales were negative? Because you're going down doesn't mean your sales are negative. You're still selling, you're just not selling as what? You're just not selling as much. All right, thank you, go.
What are you trying to find exactly?
Nothing. You're not trying to find anything. Yeah, I'm trying to go slow on this, and I don't want you to write it all out right now.
So on the test, so he's gonna.
Yeah, so on the test, yeah, you're just gonna describe what you're seeing. Okay, and I need, like, Peter first started out, said the distance is increasing over time. That's generally true. You with me? But there's more to it than it's just increasing over time. All right. You're supposed to be able to tell me what's happening here. You're supposed to tell me they got tired and they weren't running as fast there. All right. And on this unit from here to here, they're about running the same. All right. That's what I would like for you to see. All right. Now I'm scrolling down here. So it's kind of the same principle here. All right. Like if I was looking at number 17, does everybody know what the bungee jumping is? Yeah, you jump off a bridge, right? With that tether to you, right? So then all of a sudden you what? You jump off the bridge and you're going down really fast. Everybody agree? And then it snaps you back up, but you never go as high, correct? And then you go up higher and then all of a sudden your gravity pulls you back down and then here, and then all of a sudden you're at the end and you just are stopped. Does everybody agree with that? All right, that's kind of the way I would like for you to describe that. All right, yes, tell me.
So when the sales go up, like what is the time have to do with it?
Yeah, that's a very good question. So I'm going to try. I'm glad you asked me that. So there's one of two ways. Like you could consider this like in days, right? Or you could even consider this in months, right? So let's just say January, February, March, April, May, June, July, or whatever. Let's say that's what you're working for a company, right? January 1st, no one's in the business, no one's in the office, right? It's right after the holiday, correct? And then you can say from like January to February, you started making money, right? And then February to March, you maintain that sales, right? Now, do you agree there's days in between January and February specifically, right? Right, and then maybe from February to March, you didn't sell as much. And then you see what I'm getting at, right? Now, instead of saying months, I could have said hours, right? I could have said this was a 24-hour period, right? And this is what you were selling in 24 hours, right? And you could think of it as like the stock market or something that is like, you can imagine this. Think about the Amazon sales, right? How many people are buying on Amazon? Literally billions of people are buying on Amazon now. All right. So there are times when they're selling a lot more than others. At 3 in the morning, they may not be selling as much. Right. But they're always selling. All right. So those are the things that we want you to be aware of. All right. Now, you guys have to help me out with the time because I don't want to make you do all the, we have 6 minutes of class, right? Okay, thank you. So I'm always going to be changing things. So what I would like for you to do is I would like for you to do from 9 to 33 odds. 9 through 33 odds. I'm good with that. You still don't? Okay. All right, so let's go to the office. Run up to the office. Now, again, guys, we have how many minutes? 6 minutes. So guys, please don't sit there and do nothing. Work for 6 minutes and try to get the work done. Now, I'm going to tell you, if it boils down to we're deciding we'd rather sit and chit chat, then I can just change it to all of them. All right, because if you're sitting here talking, that means you don't have enough work to do. All right, so I'd like to do the odds. All right, and get to work. Take the time, try to get the work done on a separate sheet of paper, and I will be collecting it tomorrow. All right, thank you very much. Today was outstanding.